And now we have our second women speaker. We only have two. I'm so disappointed that we only have two women speaker. I love women in tech. And so Karen, you are here. So
I'm here.
Okay, you're here. Yeah.
I'm here.
Just needed to start talking. That's wonderful. Okay. So Karen, talk to us about blockchain on AI, and the floor is yours. Thanks for joining us.
Thank you so much for having me. I'm really honored to be here. And I'm going to present about AI and blockchain and how they intersect. I'm going to share my screen here.
And it's coming. It is there.
All right. Can you see my slides?
Yes.
Okay, fantastic. Okay, so hold on a second, get to the next slide. Just as background, my company, Kilroy Blockchain, we've been around for about 6 years. We have dipped our toe into AI. In 2017, we won the IBM Watson Build Challenge in North America. And we won it for our AI system called Riley. And Riley is an app that you can download onto your phone, and it's free. We give it away. We made it for people who are blind and visually impaired, and what it does is it uses visual recognition and then explains to someone who is blind or visually impaired what they're pointing the camera at. And you can download Riley if you want to take a look at it and play with it. It's on Apple. It's only available on Apple right now, and you can get it on the iTunes store, and it's or the App Store, and it is if you search for Kilroy Riley, you'll find it. And so when we were in that competition a long time ago, was when we started kind of poking around to say, okay, well, how does blockchain intersect with AI? And IBM had actually asked us about that. And so we really had to do some thinking. And the thing that we came up with is that AI is all dependent on data and algorithms. And what is it that would keep that from being tampered with? And if you're talking about telling someone blind what an object is or where to go for something, then that it really wouldn't be very good if someone had tampered with the data or the training data, or if it were corrupted or any other thing like that. And so we really started thinking, okay, how would you do this? And then in the last few years, I've written some reports, and you see them up here on the screen. One is blockchain as a service, and then I wrote AI and the law. And these are both about enterprise type level apps. That's really, enterprise level systems. That's really all we're familiar with. We don't do all the distributed finance and things like that with blockchain and cryptocurrency. So these are enterprise level reports, and they're free on the O'Reilly.com site. If you have an account already, or if you sign up, you get like a 30-day trial and you can look. Now, we're working, me and my two business partners, who are Deepak Barta and Lynn Riley, we're working on a new book for O'Reilly, and it's called Blockchain-Tethered AI. And this book is due out in the winter this year. We just started it in January, late January. And this is where we really dig into the last 4 or 5 years of research we've done on this topic. And we really get down to the nitty gritty of why you want to do it and how you want to go about it. And we're actually going to include working code samples in there so people can play on their own and try to decide if this is something you want to build into your block or build into your AI. So the reasons why we chose to go down this path, it seems like when you hear people very well-known and respected talk about AI, there's always some kind of doubt there as far as are we biting off more than we can chew? We're building a machine that is made to be able to become a subject matter expert and consume things on a particular topic better than we can. And I think when we start to build things that think better than we can, we might want to be careful and make sure there's a way that we know what it's doing and a way that we can wind it back. So I believe instead of being afraid of all these things, as engineers, what we should do is head it off and just make AI that can't do the wrong thing, AI that can't get out of control, AI that is always explainable, not just, special AI is explainable because it's XAI. All AI should be explainable. But the problem is the further you dig, it's just like you're peeling the onion. There are so many layers involved in a particular AI or any particular AI system, and these are written by many different people, from many different sources. When you use an AI environment to put together a system, a development environment, you're using libraries that other people built, and you really don't know where all these have come from. And then also too, you have your policies and then the actual run environment. So maybe something it works, it makes your AI achieve higher results, but maybe some of the tuning that you did broke the policies for how much money you're allowed to spend, for instance. So it's all a balance. Maybe the AI that you have built is for an automobile that sees stop signs, and maybe it works great in Miami, Florida, where it's sunny, and then every once in a while you have some really bad rain. But maybe it doesn't work so well in Cleveland, where it's not sunny. And it's got a lot of ice on the road. Those are just examples, but those policies need to follow those systems along the policies and environments, so you can tell whether something is likely to work. In the instance of AI is really difficult for the engineers to trace, because it's kind of like everything is in a black box, and the consumers depend on the AI's output to be reliable, but there's really no way to check it. And so as a result, as a conclusion, we need to make an interwoven AI, we need to make a way that AI is actually interwoven with blockchain. So the AI itself doesn't run without its audit trail running, and its smart contracts, and that it's tamper evident. And I believe that as software engineers, we can build this right into the AI, so it knows that it has to have this stuff in order to properly function. And then that would bring us a transparent, traceable AI system that, by its very nature, because it has blockchain as a dependency, it's controllable. Now, we dug into this deeper, and we had looked at some early work done by Donna Dillenberger at IBM, who is a research scientist. When we first started asking questions about this, she was the person who was actually on the stage at Think in 2017, I think it would have to be, and I asked her about this. What are the controls on AI? How do you control it if it's all dependent on data, and then what if somebody messes with the data? And they said that there was no way, there was no standard way. And then also too, she said that the problem was complicated by the algorithms. And so we started looking at how you could control it. And the first control that we've kind of carved out based on some of her early work is to make data and algorithms distributed and tamper evident. And so this is a way that you can build blockchain right into your data that you're using for your app, any other systems right now. For instance, we have a system called Casey that helps schools track and trace COVID cases is primarily what it's used for. It's going to be morphed into like also supporting mental health and intervention, behavior intervention type things. But all of Casey's data is has a blockchain verification. Now it's not all the data isn't stored on blockchain, because then you'd have people's names and health information stored on blockchain. But what we do instead is we can create a hash of the data and then store that hash on blockchain, which makes that data tamper evident. And this is particularly handy if that data is then going to be used for databases that get fed, for training databases that get fed into AI. Our second control is identity. And this maybe should be the first control. I mean, this is a pretty serious control, because none of the other stuff will work without there being proper identity. You could have the best audit trail all day long and the best log, but if you don't really know who did the stuff, then it's not really that good. And so the identity is something that I'm going to dive into a little deeper as we go through these slides, because it really is, I think, the crux of why you would want to use blockchain with AI, and you'll be able to figure out who did what. Control 3 is to, once an intelligent agent or a particular AI system is released to the wild, you should be able to track and trace it and monitor it, and then even go so far as to hold it accountable and be able to stop it if the behavior of the finished product is not what you want, or like it might violate policy or be used in the wrong environment. And then our fourth control is to provide the proof of authenticity through a user viewable provenance. And this would most likely be done through trust logos and brands, because someone driving a car with automated features isn't going to understand anything about data sources and algorithms, but they might understand reliably certified AI as a trust logo. And then there might be different levels of trust logos for engineers, to where maybe if they use a particular tool set that they trust, and then they'll be able to see that the contents of the so-called black box is made up of things that they trust. And so one thing that ties all these different controls together is governance. I am an IT person by trade. I've been doing IT stuff, gosh, since I was 20 years old, which has been quite a long time ago. And one thing that I know is that when projects aren't exciting anymore, they go to IT and just get poof over the wall they go, and the business units are done with them. But you can't do that with blockchain at all. You really need to, when there's a commitment to use blockchain for something, to govern a project, everyone needs to stay with the project. If there's attorneys involved, you need to keep them involved. Same thing with the executive management, any stakeholders at all. There needs to be a commitment, because it's a constant process of not necessarily consensus, but consent, where you get everybody to agree that it's okay to proceed. Now, how blockchain works? Blockchain is stored on a file system, and when a transaction is received, when a transaction is created, it's sent to each, there's nodes that are, and the nodes might be held by different stakeholders. So I may have a node as a developer, the CEO of the company might have a node, and the, let's say it's NIST or someone like that might have a node if they're not auditing what we're doing. So it's distributed. Then also too, when a transaction is initiated, it's also validated, and there's different layers of what we call smart contracts. Some of them, and some of the what we call smart contracts is actually like a workflow process where it might go to me, it might go to my manager, then it might go to the government, and they all say yes, and then it gets posted to the chain. Now, once a block is posted to the chain, its contents is actually linked with the other blocks. And this is done through a series of hashes. And if you were to take one of the blocks and change the contents, then the hashes would not compute anymore to the same value, and everything would break. And then finally, yeah, you can verify it by each node, because each new block is also added to the new nodes. Now, Hyperledger Fabric is the blockchain system that we work with at Kilroy Blockchain. We've dabbled in some other ones, and we keep coming back to Hyperledger Fabric because it's permissioned in that you can decide who can do what. And Hyperledger Fabric is produced by the Linux Foundation and a number of other partners. IBM Blockchain and Oracle Blockchain are both based on Hyperledger Fabric blockchain. So it's nice, if you learn Hyperledger, you can download it for free, do all the stuff with Hyperledger, and then you could go and implement an Oracle, implement your chain code in an Oracle cloud or IBM cloud, and you would have maybe some rework in it, but what they will provide is better tooling and security and updates and all that stuff that is worth paying for. But when you're playing, download Hyperledger, and you may want to, stay with that if you're good with all the maintenance. I think it might be similar to keeping up a mail server, where you want to, if you're going to maintain an email server, you should be ready to do that and make sure that you know how. And I would compare running your own blockchain system with that level of commitment. Now, with Hyperledger Fabric, you have a membership service provider that is part of the system. So you can actually issue identities to different people and even AI to prove who they are and where they came from. And then this is a real complex looking diagram, and this is out of the Hyperledger Fabric documentation. You're welcome to look this up. This is an MSP diagram that shows how that works, when it issues the permissions. And you've got, but the basic crux of it is you have a way to issue certificates that are based on the X.509 standard. And then you have a way to associate organizations with the certificates, and then also channels, something called channels, which is represented by the C here. And the channel would represent like a certain type of activity. And so both of these things are listed in the certificate that is issued and to the participants. And then that allows the different participants to have permission to do things on the various channels. And we're explaining this in depth in the book. My business partner, Deepak Barta, is much more good at this part than I am. And I wouldn't want to do it injustice by continuing to try to dig in. But what I will say is that everything is here for you to know who somebody is, set up a certain channel for them to talk about some particular topic. And it's like, a TV channel on cable, maybe they're talking about identity management. Maybe they're talking about the recent things that have happened to that AI. Maybe they're talking about the policies that were set. Maybe they're talking about the ODDs, which is the operational environment that is used for self-driving vehicles. So, the channels, you can have any number of channels set up with any number of different topics. Now, one of the ideas we have on a good place to insert this type of activity is in the machine learning operations cycle. And for those of you who aren't familiar with that, like I mentioned before, I'm an IT person, and so I was always like an admin type person, an OS2 admin, and I was a LAN admin, and I was a Lotus Notes admin, and a web admin, you name it. And part of that is being able to deploy the code. And with this type of a operation, it's real similar to DevOps, where you're getting updates from the developers, you're deploying the code, you're doing some testing, deploying the code, checking to see what's going on. Next change comes around, you deploy that code again, and a lot of people use Jenkins for that, for part of that process. With ML ops, machine learning ops, it's very similar, except for there is a round of training. It's where now you've got all the other stuff going on that has to always happen when you package up a system and ship it out. It might get containerized and then put on a server. And now, except you've also got this training pipeline and this whole model of doing experiments and machine learning on your model before it goes out. So creating simple tethers for AI is a good way to build yourself the back door to the system. And I don't mean it in a sneaky, hackery type way. I mean it in like, we're human beings and we should be able to shut this stuff off. There's, I don't know if it was Black Mirror, one of them I saw not too awful long ago, where they had a factory that shipped shoes out to people, and everybody was dying because the factory was creating so much pollution, but the shoes kept coming and kept coming, and pretty soon, like, there's only a couple people left, and there's just shoes everywhere, and the sky is all black from making the shoes. And in this particular story, there was a programmer who remembered that she had made herself a back door and she was able to shut it off. So, that's a little science fiction for you, but it's all stuff to think about. And so you can create tamper-evident hashes. We don't really call blockchain immutable so much, because someone can get in and change anything if they want to. They can change the data on a file system. But the thing is with blockchain, it would be evident. This method also makes it traceable, so you always know who did what. And as we get into things like where programs are the ones writing the code, it gets a little iffy and dicey as to, okay, who really did this? But we can assign these types of identities to the AI itself. And then it can create a permanent record of the AI governance. And the thing is you can always remember what it was supposed to do. A lot of these things will last way after we do, they'll be around after we're gone. And so it's good for there to be some kind of record of the original intent and what is done to get to where you are. And that's what I had to talk about. And I just want to remind you about these two are free. You can get them anytime, and this is coming this winter. And if anybody has any questions, I'm happy to take them.
I am pretty sure we have questions. And we have also a bunch of shy people. I can't believe that there's no more interactive questions. So how did you, my question, how did you get into this field? Because, and when did you start? Because, okay, you've read a couple of books. So you started what, like 5, 6, 10 years ago?
We started in the blockchain AI area about 6 years ago. My business partner, Deepak Barta, and I have worked together for more than 10 years. We're e-commerce developers, and we worked in Magento e-commerce, which is really hard. So that's how I've convinced Deepak this whole time to keep going with this. I'm like, come on, it's not as hard as Magento. And yeah, we've done it, little at a time, really, and a lot of struggling, and a lot of putting our heads together. And Lynn Riley, shout out to Lynn. She may be on here, I don't know. She's my other business partner, and she has gone down the data science realm of this, and then also too the whole self-driving car thing. The data science Lynn used when she was training Riley, which is our app that we give away. And Riley, we were training it to recognize candy. And because we were going to CES, which was a circus, we were going to CES. We wanted to give away candy, and we wanted to show people how Riley could recognize what kind of candy it is. And so Lynn had to learn how to do all that. And so she figured out, okay, all these things are a Tootsie Roll, and then all these things aren't a Tootsie Roll. And so she'd have to give it hundreds of objects. And so, like, you give it a rolling pin that isn't a Tootsie Roll, right? So a stick, that's not a Tootsie Roll. And yeah.
No, it's funny you make a reference with candy. I remember when I was finishing my college, it was the very, very early stages of e-commerce, no Magento yet. And my end of my master's project was a store that's selling candy. So,
oh, that's funny. That's funny.
We have a serious question from Erdogan. So let me translate that. The way blockchain is designated is designed is problematic. Every record is saved in every node. So much waste of space first of all, so much computational power lost. This is just blockchain as a small app. How do you replicate to all this of apps? Very problematic, very bad design. What do you think?
I think that there's a lot of wrong assumptions in that statement, because I believe that he's familiar more with public blockchain and cryptocurrency and the whole proof of work. The whole way that the nodes, the consensus is made, everything is completely different. There's no miners with enterprise level blockchain. And then also too, it's completely false that you have to put all the data on it. You're the one deciding what goes on there. So you only put enough on to make sure that you know that everything is still correct. And so how you architect this is really up to your own imagination. If it's something as simple as, I want to know Deepak introduced this data set, and I want to know that it is still the same anytime that I check it, then you can just put blockchain to run right alongside your database and just use it to monitor and check. So yeah, it's not as inefficient as you would think it would be, and it's understandable how you would think that because of the way that cryptocurrency runs. Okay,
so Erdogan, Karen, you can continue the debate on Slack. I love the idea. I love the exchange here. We've got to move to our next session. Thank you, Karen.
Thank you.
Artificial intelligence,
data, analytics,
user group,
AIDAUG.
Join AIDAUG today.